Hey guys, Nitro here. Today we are back with another video in which we'll recreate the warp strike from Final Fantasy XV. This video was inspired by Mix and Gem's video. Make sure to go and check him out, he does some quality content and recently blew up. Back to our video, this will be a step-by-step tutorial, so almost everything will be included besides some useless things that I thought don't really matter. On the screen you can see the comparison between my final result and the in-game gameplay, and there are clearly some differences like the animations, but the others should be easily tweakable. Before starting, if you want to understand something, let me know down below so I can help you out. As well, if you want to learn more about Unreal Engine 4, both its features and how to recreate mechanics, level design and game development in general, consider subscribing so you don't miss out on any of the upcoming videos. And now, without losing any more time, let's dive right into the topic. Okay, so here we are in an almost default third-person template. There are some things that I've changed, such as the animations, I imported some and the skeletal mesh, and here are some enemies, but these are only characters for now, which have no functionality at all. Right, there's nothing in here, we are going to set it up a little bit later. And now, the first thing that we should do is to see how we can set up the animation blueprint for this guy. Let's go in the animation class and let's get in here. And this is as well almost default. I deleted here the isInError variable and the try get point on her and is falling. And then also in my event graph, animation graph, right here in my main state, I'm only going to have the idle and running state, not the jumping and falling states as well. So from this one, what you'll need to do is to add a new state, and I'm going to call this warp. Okay, we should also plug this from here in the first one, so we have two transitions. Then let's get in warp, and in here I already have an animation. Let's go into it and let me show you. So this is my animation, right? It's from XMO. Now I'm going to go in here, drag and drop it in the graph, and straight plug this in here. Okay, now if we are going to compile, we are going to get two errors. And these are from the transitions. There is nothing in here, so we don't know when we want to transition from the one to the other. How we are going to do that is based on a variable. So the first thing that we'll do is to go in our third-person character. And now in here, we are going to create a new variable. And I'm going to call this isInWarp. I'm going to compile, and by default, this is going to be false. Back in our player animation blueprint, we are going to go and get event blueprint begin play. Then we are going to cast to third person character. Let's see, third person character. The object is going to be once again the try get pawn owner. And then what we want to do is to promote this to a variable. I could call this player. Okay, so this event is just like the begin play from all the other blueprints. When the game is going to start, this is going to be fired. And then we are going to get a reference to our player, and then we can access its variables later. Let's create a new variable, and I'm going to call this isInWarp. Just like the other one, by default it's going to be false. And we are going to set this based on the player variable. So we are going to drag this in here. And then we're going to get isInWarp, and then we are going to set it. So we're going to set the variable that is in our animation blueprint based on the player variable. Plug this in here. Now let's compile. We still have these errors, but we need to do something else in here. We will need to get a delay right after this speed set, and the delay should be very low, something like 0.01. The reason why we are doing this is because there is usually a problem between the player and how we get it from the begin play and the update animation, right? So the first frame, every time you're going to play the game, the player is going to be missing, and that means that the player is empty and we cannot access the variable, which means we are going to get an error in our here in the developer tools in the output log. We are going to get an error in here. And because we don't want to get those, even though they're not going to be game breaking, we will have here a delay to make sure that we are first going to get the player, the first frame, and then we are going to set the isInWarp. Okay, let's go back to our transitions and go to the one from idle to warp. And in here, what we need to do is to drag our boolean get an equal to, set this one to be true. So if is in warp is equal to true, then this is going to be able to transition, and then we can copy this and then go to the other one and set this to be false. Okay, now what we can do is to go and have here a button, let's say Q for this one, get a flip-flop, yes, get a flip-flop, and just try to see what happens if we are going to change the values. Okay, the first one is going to be true and the other one false. Let's compile and let's check. So I'm going to press Q, and as you can see, this is now going to play. So everything is working fine. If I'm going to press once again Q, it is going to go back into its idle and running animation. Okay, I think that's pretty much everything we have to do for now in here. So let's go and see how we need to set up our enemy for now. Before going on and configuring our enemies, the first thing that we'll have to do is to get an image that is going to be a cross or something alike. And this is what I have right here. It's a PNG, so it has no background. It's only this cross right here and these circles. Now what we want to do with this is going to be a cursor that is going to indicate for the player which enemy is selected for the warp. So now let's create a new widget blueprint. I'm going to call this W_cross. And this is going to be used as a 3D widget in our world, so it's not going to be on the screen of our player. Let's go to fill screen and set this to be custom. The width and height are going to be the width and height of our image, that being for me 400 and 400. Now let's drag an image in here, set the position to be 0 and 0, size 400 by 400, and then we can set the anchor in the middle. Now the brush is going to be the cross, and now everything is set up in here. There's nothing else that we have to do. So let's close this down and now go into our enemy. And the first thing that we'll do is go in the viewport and create a scene. Okay, doesn't matter where this is located. Actually it does. We have to set it somewhere around here at the top, but it doesn't matter where on X or Y it is. Okay, then to this scene, let's attach a widget. We're going to attach this in here, and the widget is going to be our W cross. So now you can see it in here, but it's currently too big, and we don't want to show this by default. So let's set the scale to 0, so it's going to be basically invisible. Okay, and now in our event graph, what we'll do is to see when we want to show the cross or not. So let's get here event begin play, and then get a set timer by function name. Function name is going to be set later, the time is going to be 0.01, and we are going to check looping. Now let's create a new custom event. So a custom event, and I'm going to call this get player. I'm going to copy the name and set it in here. So now this function or this custom event is going to be called every 0.01 seconds. Now let's get from here a sequence. And we're not yet going to set up then 0, we're going to start with then 1. Let's get here a branch, and now we want to see when we want to show the cross or not. So first we're going to create a new variable, show cross, and by default this is going to be false. Okay, now based on this value from the variable, we will show the cross. Let's get an add timeline, and I'm going to call this cross the L from timeline. And now from true we want to play, and from false we want to reverse. So when this is going to be true, we want to show the cross, and when this is false, we want to reverse it. So we are going to unshow it. Let's get a new float track. I'm going to call this lerp. Add a new key, time 0 value 0, and then time 0.5 and value 1. Let's set the length to 0.5 so it fits the entire thing. Now let's compile and get back in event graph. Here what we'll have to do is to set the 3D scale of our widget. So set 3D world scale. Okay, but we're going to do this based on a lerp. So if you don't know what lerping is, let's say that we have two values. We have one that is 0 and one that is 2. So let me get here a lerp. Okay, so let's say that we have the value A0 and the value B2. And let's say that our alpha is going to be 0.5. Then the return value of this lerp is going to be right in the middle, that being the value 1. if this is going to be 0.25, that is going to be, I think, 0.5. And then if this is going to be 0.75, this is going to be 1.5, and so on. So basically, it is going to get the absolute values, it is going to add them, and then it is going to divide them by this alpha, right? So if this is going to be 1, it is going to be b, and if the alpha is going to be 0, then the return value is going to be a. But we are not going to use the lerp, we are going to use a node called is, which is going to have a smoother interpolation between the two based on a function here, and we are going to go and get expo in and out. The alpha is going to be our lerp track. And now let's see what we are going to do with a and b. For a, we are going to get a widget and get world scale. And now for b, we are going to have here a select node. The index is going to be our show cross. Okay, then let's have to make vector. Okay, now let's leave the first one to 0, 0, and 0, and the other one to 0.2, 0.2, and 0.2. And now we want to plug the first one in false, and the second one in true, and the return value in b, and the result in new scale. Now let me explain. The select node is going to select between two values based on a boolean or an integer or whatever. That means that if our show cross is false, we are going to choose this vector. If it is true, we are going to choose this vector. So if it's false, naturally we don't want to show the cross, which means that the scale is going to be 0. But if this is true and we want to show it, it is going to have a slightly bigger scale. Now everything should work just fine, and we can leave this right here at the bottom, and then we can start working on then 0. The first thing that we'll do is to get a line trace by channel, and this is going to be a line trace from the enemy to the player. So get actor location, copy this, then get player pawn, log this in the target, and then this in the end. Then from out hit, we are going to break this, so break the hit result, and let's subtract the start from the end, get the length of this vector. Okay, and then let's check if this is bigger or equal to 150. So 150, a branch, and then if this is false, we are going to set the visibility of the scene, so set visibility to false, and then this is also going to propagate to children. As well, I renamed the scene to warp location because this is what it is going to be basically. This is where we want to warp. Okay, then do the same for true, but instead of false, we are going to set this to be true, and as well propagate to children. And now what we'll do is to get actor location, then get unit direction vector, then from trace end, we are going to multiply this. So vector multiplied by a float, we are going to multiply this by 100, and then we are going to add to this vector the word location, the actor location. So vector plus vector, and add this one in here. Let's split the struct bin, and then set the warp location. So set the world location of the warp, set world location. Actually, we can set world location and rotation, because we are also going to set the rotation of this. The location is only going to be the X and Y, and the Z is going to be the one that it has in that moment. So get world location, split the struct bin, and only plug in the Z. Then for the rotation, we are going to get the world location once again, get world location, and then find look at rotation. The target is going to be the trace end, and then plug this in the rotation. And don't worry, I'm going to explain this once I finish this, the entire thing with the enemy. Then get the widget, set world location. Actually, no, we don't need the rotation, we just want the location, set world location. And then this is going to be similar to the other one, but instead of multiplying by 100, we are going to have it 30. Okay, so only 30. Okay, plug in the X and the Y, and the Z as well, get the world location, and then plug this in the Z. Now everything is done in here. Let's check and see how this looks, and then I'm going to explain. I'm going to add here a cube, right, to see what's going to happen. Size is going to be 0.1, so no, it's going to be 0.2, and make sure that this is not attached to the widget and it's only to the warp location. Can't seem to see it. So, okay, now I can see it. Okay, let's set the size once again, and now let's play and see what happens. So now you can see that the cube is going to follow us no matter where, and it's 100 units away from the character, right? The distance is 100 units, and it's also going to follow our player. Now let me explain what everything does in the event graph. Here, by subtracting these two and getting the length, we are going to get the distance between the two actors. So here I'm going to have something that can explain this a little bit later. It's going to help me. So this here is our line trace, which is also the distance between the two actors, right? And by getting the length, we get the distance between the enemy and the player. Okay, then by getting the unit vector, this is going to be the vector direction from our enemy, always our enemy, to the player, but it's not going to have a value, right? So it's only going to be the direction. By multiplying by 100, we are going to get that distance with the cube, right? The 100 distance away from the mesh. And by multiplying by 30 for the widget, this is going to be closer to the mesh. Because we don't want to have the mesh, we don't want to have the widget as close to the warp location. Okay, so by setting this, you saw the effect, right? The location. And then we defined the look at rotation that is always going to orientate the widget and also the warp location towards our player, right? So it's always going to face the player. Okay, I think we are done in here. We can compile and close this down. And now we can go and see what we have to do in our player. So let's open it, right? And now let's start to see what we have to code. Okay, so the first thing, we are going to get event begin play. And then once again, a set timer by function name. Set looping to be true and the time to 0.01. Let's create a new custom event. So add custom event. And I'm going to call this, let's say, check enemy. I'm going to copy the name, paste this in the function name, and then I'm going to get here a branch. And we are going to check if we are not in warp. Right, so we're going to use a boolean, a not boolean, and then plug this in condition. So if you are not in warp, we are going to have here a function. I'm going to call this check enemy underline f, and we are going to fire this function. Okay, now let's create a new variable. I'm going to call this lowest length. It's going to be a float. And then inside here, I'm going to create a new local variable. I'm going to call this enemy length map. And now this is going to be the following. First, we want here enemy, right? So enemy character. Then set this to be a map. And then the other one is going to be a float. Now let's see how we set up this function. The first thing that we'll have to do is to set the lowest length to be a very big number, right? So just input here as much as you want or as much as you can. Let's compile and now let's go in the viewport. To the follow camera, let's add a cone. Okay, let's make sure that this is facing the right way. Okay, so I'm going to turn on snapping here. I'm going to rotate this. So 90 degrees. Now make sure that this is quite big, I'd say. Right, okay. I'll just make this quite big. Okay, then also we need to make the base bigger as well. And as well, again, very big. Because this is going to be the visual cone in which enemies have to be in order to warp at them, right? So if enemies are not going to be in this cone, then we are not going to be able to warp at them, because we will need to have a way of checking if enemies are in here. So we are going to do that by using this cone. And as well, we will need this to be very big, and if my mouse wouldn't bug so much, I could actually set this to be big enough. Okay, so I think this is good, right? It's a pretty big amount, maybe even make the base bigger. And then of course we do not want to be able to see this in the game, so we are going to check here hidden in game and also uncheck visible. Then at the collision preset, check no collision, or in fact we want to overlap all. Okay, and now we are going to use this as a collision volume, right, as we would use the box collision or the sphere collision and all the others. Okay, now let's go in our function, and what we'll have to do is to get the cone and get overlapping actors. The class filter is going to be enemy, and then from overlapping actors we're going to get a for each loop. Okay. Alright, so now we'll get our map that we just created, and we're going to have here add. Okay. In the enemy, we are just going to add an array element. Okay, so you see that it's not working. Oh, I know why. First we will need to cast. Right, so we'll need to cast to enemy. Right. The reason why we need to cast is because our map is not going to know that we are going to filter this by the enemy character, right? So it doesn't know that the array element is already a character, an enemy, right? So we will need to cast to it. Okay, and now we will need to see what is the distance between our player and our enemy. Firstly, I want to say that I'm going to set the distance between my player and the enemy based on the screen and the center of the screen, and not physical distance, right, vectors and all that. What we'll do is to get from array element, get actor location, and then we are going to get player controller, and then we will need to have here screen, so project world to screen. Actually, no, we will need to get convert world location to screen location. The world location is going to be the world location from the actor location from our array element. Okay, then we are going to subtract a vector 2D, but this is going to be the second pin, and the first pin is going to be the center of our viewport. That means that we will need to get here the viewport size, so get viewport size. Then we will need to multiply both of these by 2, so divide by 2 and the other one as well. Then make a vector 2D. The first one is going to be the x, and the second one is going to be the y, and then this is going to be the first pin. Let me explain why we have to divide by 2. Let's go inside our widget cross, because this is going to be a little bit easier. So let's say, for instance, that our screen here is going to be 400 by 400. By dividing by 2 both of them, I'm going to get 100 on the y and 100 on the x, and their intersection is going to be right here in the middle. And that happens with every viewport size by using this dynamic way. Right, so now we are going to get the distance between the center of the screen, right, this one, and the projection of our enemy on the screen. Then let's get the length, vector to the length, and that is going to be plugged in here. Okay, let's make this a little bit more cleaner. Now we will need to do something from completed, and let's see what exactly. So from completed, we are going to get enemy length map, and we are going to get the keys being the enemies, right? And then once again another for each loop. Okay, then from the array element we are going to get a set show cross. We are always going to set this to be false. Okay, then if the array index is equal to 0, then we are going to do some things, right? So if this is always going to be the 0, so for instance, if the keys are going to be, there's only going to be one key, That means that if this is 0, we'll want to automatically set some variables. But if it's 1, 2, or 3, right, the array index, then we will want to see if the length between the length that we added here is lower than the one that our current enemy has. Then we are going to set that one to be the enemy to warp and the length. Let's create a new variable, enemy to warp. This is going to be a normal variable and it's going to be an enemy character, right? Set enemy to warp it is going to be the array element. Okay, and then we are also going to set the lowest length to be, so we'll need to get here find. We're going to find the length, right? Length, and plug this in the lowest length. Okay, so now we know the length that our current enemy warp has, right? So we know the lowest length that we have now, and we are going to compare that to the other enemy to warp. Then we're going to have here a branch, and we will need to have another lowest length. We'll check if this is lower or equal to, but it's going to be the second pin. Okay, we'll plug the find that we just got here in the branch. So if the current enemy that we are checking for has a lower length than the current lowest length, then what we'll do is to set the lowest length to be this one. Okay, and the enemy to warp is going to be the current array element. Alright, so this is a little bit harder to explain what exactly I'm doing here, but if you're going to take everything from here and look at it and what actually happens, it's going to be probably easier to understand than what I have explained. Right, so we are basically checking for the distance between the center of the screen and the enemy to warp, and we are going to set the enemy to warp to be the one that's closest to the center. Then from completed, we are going to get enemy to warp and set show cross to be true, because we set this to be false right here, right? Let's compile and let's see if this is working or not. Okay, so you can see we have these cubes that we have to delete because they are getting in our way and we don't want that. Delete, compile, and now let's see. Okay, so you can currently see the cross. It's not really that visible. Let me change something in the character. From the camera boom, we will need to add here, let's say 50. See, this is working. Okay, so as you can see now this is a little bit more to the right, and you can clearly see the cross. And there's also a bug, as you can see, it's going to go upwards, which is not what we want if you get too close. And that is basically why we wanted to have here a value, but it seems that 150 is too low. Let's see 300. Okay, so 300 is just good, right? It's going to get its job done. And as you can see, everything is based on the center of the screen, right? So to whichever I'm pointing, that is going to have the cross that is going to work. Okay, now what is left to do is to see how we are going to warp and what we have to do while we are doing that. Okay, so first things first, let's go into edit, project settings, and set up an input action. Let's go to input, input action, and create a new one. I'm going to call this warp, and it's going to be bound to my E button. Of course, you can bind this to whatever you want. Okay, now I'm going to get here warp. Let's create a new variable, and this is going to be called can warp, right? Because we will want to have a delay, of course. By default, this should be true, and we are going to check at the beginning if it's working, if it's true or not. And if it is, we want to see if we have any enemy to warp to. All right, so we're going to check if this is valid. And if this is true, we are going to set can warp to be false, then is in warp to be true. And there's currently one problem. We do not want to be able to move while warping. So let's create a new variable called can move. Okay, by default, this is going to be true. And then we will need to go here at movement input and have some branches. So at both nodes, we want to check if we can move or not. And if that is true, we are going to add movement input. But if it's false, we don't want to do anything. can move. Okay, so the same thing here and here. Now let's set can move to be false. And what we can do here is to make this a function. So warp variable. Okay, let's see, warp boolean sets. And then in order to set this dynamically, we are going to have here inputs. And the reason why we are making this a function is because we are going to have this piece of code multiple times. So can warp false is in warp true and can move to be false once again. Then what we want to do is to set the rotation of our player to be towards the enemy that we want to warp towards. So set actor rotation. We're going to have a find look at rotation. The start is going to be the actor location, so get actor location, and then the target is going to be the actor location of our enemy to warp. Okay, now let's have here a delay, and we're going to have a delay of 1, and now we are not going to do anything yet. And actually the reason why we are having here a delay is because as you saw in the beginning, we are not going to instantly warp towards the enemy. We are going to have a little animation playing, and then at some point in the animation we are going to warp. And with the settings that I have at my animation and the length, right, 1 is just exactly when I want it to happen. So if now I'm going to press E, you're going to see this is kind of working, right? But I cannot move, this is not going to stop, and basically nothing is going to happen. Only this animation is going to start playing, and it's going to start playing towards the one that I'm looking at, right? So as you can see, it's working pretty fine, this set actor rotation. And now we want to see what is going to happen after 1 second. So what we're going to do from now on is that we will need to set a lot of things like variables and some components that are not yet created. So let's create them right now. We are not yet going to set them, but at least we're going to have them referenced. So with the mesh, we're going to attach a new static mesh. That is going to be a sword for me, right? I'm going to have this sword, and then we will need to set a new socket for this sword. So let's go into our skeleton here, and we will need to get the hand, then right click and add socket. I'm going to call this sword. So F2 sword, right click once again, add preview asset, and let's choose the sword. Now let's see how we want to set this up. First, let's set this guy to have an animation playing, just so we can see it better. Let's see where I can set one. Well, I don't think I can set one right here, but anyway, I think I'm able to put this in a good spot. Right, I'm going to disable the snapping. Okay, so let's see where we can set the animation, because we really need one right now. Let's see. There should be one. Here, preview animation, sword and slash. This is exactly what we need, because this is the animation that we are working with. And let's see. It seems that I got a pretty good socket. Maybe you can set it like this, a bit more down. I think the position is really good right now. Maybe just adjust it a little bit. Right, so let's see, just a little bit. Okay, just like this. Yeah, now it should be good, and no problems with it. Now let's just apply. Right, save. Now I think that's everything we have to do. Okay, let's close this down and also close the mesh. Now let's go into third person actor, and here go to the sword, get to the parent socket and search for the one that we just created, that being sword. Now we can see he's going to hold it in his hand. He doesn't have a holding animation, but let's just say that he's holding it. Okay, now if we are going to go and press E, you're going to see the sword following his hand, right? This is exactly what we want. Now let's go here, and what we'll need to do is to create a new variable. Okay. And now I'm going to call this current location. It's going to be a vector. Compile. and this is going to be the location of our actor. So get actor location. Okay, this is going to help us when we are going to interpolate between the location of our actor, right? The location of the actor and the world location from our enemy, right? The cube that I showed earlier. Then we are also going to get a new vector and call this sword location, because we are also going to interpolate the location of the sword. So get a static mesh, get a world location, then get world rotation, because we are also going to need another rotation, sword rotation. Let's plug this in here. Okay, and now what we need to do is to go and create, this is going to help us with the effects. So in the blueprints, we will need to create a new material parameter collection, and I'm going to call this, let's say, mesh effects. Okay, and I'm going to call this, we are going to need a scalar parameter, and this one is going to be called, let's say, just blue opacity effect. And by default, let's see, I think we want this to be 1. I am not sure, maybe, yeah, I think 1 is what exactly what we want. Or actually no, we want 0. We don't want this by default to be 1, and you'll see later why when we are going to apply the effect to our mesh, the skeletal mesh. So set scalar parameter value, collection is going to be the one that we just created, and parameter name blue opacity effect. Okay, parameter value 1, and now we will need to somehow stop the animation that we are playing from our mesh. So let's drag this one here, set global anim rate scale. So this is almost going to stop the animation from playing, but we're not going to set this to be 0. Let's say 0.3 is going to work well with this one. Maybe you can play around with the animations you have and see what's going to fit you the best. Then we're going to get the mesh and we are going to hide it. So set visibility, and this is going to be false, and we are not going to propagate to children, right? We do not want to do that because it's not needed, because we still want to see our sword. Okay, let's compile, and then here we will need to create that static mesh that is behind us, not the static mesh, actually a skeletal mesh that is left behind our character. So let's create a new function, create skeletal mesh, and let's see how we should set this up. The first thing that we'll get is a spawn actor from class, and the class is going to be skeletal mesh. The spawn transform is going to be the transform of our mesh, so get world transform. Okay, and now we should always spawn this, right? So always spawn, ignore collisions. Then what we can do, what we should do is to disable collisions. So set collision enabled for the skeletal mesh and no collision. Then we are going to set skeletal mesh, because currently there is none. It's going to be the Xboard that I have. Then we'll need to set the materials, set material, and we'll have this twice because there are 2 materials on the skeletal mesh. So from 1 for the element index 0 and 1 for the element index 1. Okay, then we should play animation, but not for our mesh, for this guy right here, the skeletal mesh. And the animation is going to be the sword and shield slash. Then we are going to set position. Okay, set position. What this does is going to set the position that we want the animation to be in, right? So the exact time, and the in position is going to be an input. Okay, then we are going to set as well for the skeletal mesh, set global anim rate scale to 0 because we do not want this to be played. And then we are going to have here a return value, a return node with an output that is going to be this return value from the spawn actor from class. Okay, compile. Now we will need to create, okay, so there are some errors, let's see. Oh, this doesn't have a connection. Right, and now there is still a problem in here. We are not having any materials to be selected, right? We will need to create some special ones. So let's see how those should be created. Let's first get here and create a new material. New material right here, and I'm going to call this mesh fade. Let's enter and let's see how we are going to create it. The most important thing that we need to make sure we do is to go and set a blend mode to translucent, and also make sure that you check here used with skeletal mesh. Okay, then what we'll do is to get a final node, and the exponent is going to be 2.5, right? And the base reflect is going to be 0. It's actually going to be 0, right? Plain 0. Then let's get a vector tree and set this to have a blue color. Let's multiply these two, and I'll also multiply this multiply node by a value, so we are going to get a nice glow. Okay, let's set in here 40, and now we are going to get a nice emissive color, and the opacity should be the final node. Right, you can also set the exponent to be 3, I think that's going to work even better. Right, now let's save and wait for the shaders to compile. Now we can see how this looks in game. But before doing that, we'll need to make sure that we assign these materials to the mesh, because if you're not going to do that, it's never going to work, of course. So this is how it looks right now. And now let's select it and just click on this arrow. Now let's go in our event graph, get the create skeletal mesh, set the in position to be 1 because we waited 1 second right here. Then let's promote this to a variable and name this clone. So we're going to have a reference to it. Now let's play. Let's see how it looks. If I could play. Alright, I'm going to press E. And as you can see, the clone, the sword dropped, but we are going to fix that a little bit later. Okay. Now what we want to do is to, in fact, we want to get our sword and detach from component. We want to keep world for all of them. Okay, and now one more thing that we will need to do is to go to our mesh, get a particle system. I'm not going to name this, right? So go to it, place it somewhere here in the middle, go to activate, to auto activate, uncheck it, and then here, you know, event graph, get it and activate with reset to be true, because we are going to have some particles that are going to spawn while we are going to dash, while we are going to warp, but we haven't created them yet, so we are just going to have these placed in here for now. Okay, what we can do, so this is going to look a little bit more clean, is that we can select all of these nodes, compile and collapse this to another graph, and I'm going to call this warp sets. Right, you can name this however you want. Okay, just place this in here, and now we'll also need to have an output and call this, and this is going to be an exec, so an execute pin and then output. Okay, now let's compile and see what we have to do after this, after these nodes right here. The next thing is going to be a timeline, so add the timeline, and I'm going to call this lerp once again. This should always be play from start, and now we are going to use this to interpolate the location and for both the character and the sword. The first one is going to be the character interpolation, right? So we can have two. The first one called character, add a new key, time 0.05, value 0, and 1 at time 0.4 and value 1. The length is going to be 0.4. Okay, for the sword, this one is going to be from 0.5, value 0, and then time 0.3. This is going to end a little bit faster, value 1. Then we're going to get here an FOV, right? Time 0, value 75. Also, this is the FOV for my follow camera, right? If you have some other value in here, you can set that to be for your timeline. Okay, let's go back. Now add a new key, time 0.13. Okay, value, let's say 65. Then 0.38, value 65 once again. And then time 0.4, 75 once again. Let's see all the keyframes. Okay, now we can see them. There should be a new key, a time 0.1 and value 75. 75. Now we are going to go and set the key interpolation to be on auto. So we are going to get this nice shape right here, this smooth shape, which is going to look nice in the end. Might look weird right now, but it's going to look nice on the FOV later. Okay, and if it's not going to look right, we can change it a little bit, tweak it to get the perfect FOV playing. Okay, back in event graph, we are going to get set world location. So set actual location. Okay, update in here, and the location is going to be, once again, we are going to interpolate with the is node. The function is going to be expo in. Okay, the alpha is going to be the character for this set actor location. The A is going to be the current location, and B is going to be enemy to warp, get warp location, and then get world location. Okay, plug this in the result. Then we're going to get the sword, set world location, and once again we're going to get the is, plug this in the new location. The A is going to be the sword location, and B is going to be, once again, the warp location. Okay, and alpha is going to be the sword, and we can also set the rotation, so set world location and rotation. Okay, the location is going to be the result, and the sword rotation is going to be, right, the new rotation is going to be the sword rotation. Now let's also get the follow camera, set FOV, set field of view, and now the in field of view is going to be the FOV track. Let's compile and let's see how this looks. Right, so currently this is not working, and let's see why. Okay, so the reason why this wasn't working is because here in our collapsed nodes, we haven't plugged this in the output, and now let's see. Okay, so you can clearly see how this is going, right? Let's do that one more time. Okay, so maybe the FOV is a little bit too sudden, so I'm going to set the time to be 0.08, for example, and this is a little bit too much. Okay, perhaps for this one as well, something more like this. Okay, now let's see. Yeah, this is a little bit nicer than before. Okay, and now the only thing that we have left to do is to set the unfinished nodes, right? We will need to reset a lot of the things. So let's see how we are going to do that. And also, after doing that, we are going to set the particle system, make a quick particle, right? Something that's going to look nice. Now let's see how we are going to set the finished. Okay, so the reason why this wasn't working is because here in our collapsed nodes, we haven't plugged this in the output, and now let's see. Okay, so you can clearly see how this is going, right? Let's do that one more time. Okay, so maybe the FOV is a little bit too sudden, so I'm going to set the time to be 0.08, for example, and this is a little bit too much. Okay, perhaps for this one as well, something more like this. Okay, now let's see. Yeah, this is a little bit nicer than before. Okay, and now the only thing that we have left to do is to set the unfinished nodes, right? We will need to reset a lot of the things. So let's see how we are going to do that. And also, after doing that, we are going to set the particle system, make a quick particle, right? Something that's going to look nice. Now let's see how we are going to set the finished. Okay, so let's drag from finished a sequence, because we are going to have two things happening. Now let's go and get our sword, and we will need to attach to component. This is going to be the target. The mesh is going to be the parent, and the socket is going to be sword. We are going to snap to target, and snap to target. Only keep relative to scalar. Actually, we can keep world. Okay, plug this in, then 0. Then let's get our mesh, and we are going to set visibility to be true. Get it, and set global enumerate scale to be 1. Okay. Then let's get a set position. Once again, it's going to set the time for the animation 1.28. Then get player controller, and we're going to have here play camera, client play camera shake, and I already have one created. Right, that is because the shakes are usually trial and error, right? You just need to try and see what works the best. This is what I have: oscillation duration 0.3, blend out time 0.5, and then for everything here 2 and 12, right? Only the FOV oscillation is default. Okay, the scale is going to be 4, and then here we are going to have a delay. The delay is going to be 0.84. Then we are going to go once again to warp bool sets. Set can warp to be true, is in warp false, and can move to be true once again. And this is basically, right, so what's happening here, the delay, is because that's how much it is left from our animation, 0.84 seconds. Right, we are going to set the 1.20 because that's where it looks the best, right, when it's going to land. Okay, now let's see how it looks now. Okay, so it's looking pretty sweet. We can still see the clone here, so what we can do from then 1, we will need to have here a delay though. That's going to be 0.2, get a clone and destroy actor. Okay, and now what we'll have to do is to have that sweet blue tint and edges on our character once again when we are going to fall, when we are going to land in front of the warp, right? So let's see how we are going to set that material up. Let's go into mesh, and we are going to get the beta high limbs, the white one, right? And now we will need to set this up. So let's get a vector 3 first, again a blue tint. Then we will need to get another Fresnel node with exponent 1 and base reflect 0. Let's multiply these together. Okay, then we are going to multiply this by another value, right? So that this one is going to be once again 40, just like the other one. And then we are going to multiply this with a scalar parameter. So we're going to get here collection parameter. One is going to be mesh effects with a parameter named blue opacity effect. Plug this in here, and then that goes in emissive color. Let's save. Okay, so now this is going to save everything, and by default this is 0, so you're not going to see any changes right now. But this is why here in our collapsed nodes we are going to set this to be 1 at some point. So it's somewhere around here, let's see, right here. This is why we are going to set this to be 1, because we want to have that effect once we are going to land from our warp. Okay, so back in event graph, right, we are going to have here a timeline. So add timeline, LERP 1, doesn't really matter how you name it, play from start always, float track, that goes from time 0 value 1 to time 0.5 value 0. The length is going to be 0.5, and then we're going to set scalar parameter value, collection, the mesh effects, blue opacity effect, update, and new track parameter value. Let's compile and let's see how this looks now. Okay, so you can clearly see now the effect, that sweet blue edges that we have. right? And now there are two more things that we have to do. First, we will need to fix this animation problem that is going, right, is going to teleport because it's going forward. So I suppose that if you're going to go for a bigger project and you're going to have this mechanic, you're going to have better animations which are going to be in place and you're not actually going to move forward. Or perhaps you're going to have root motion, but since I do not have better animations and I'm not in any way of or shape an animator, I'm not going to try and fix this myself. So I'm going to go for something that's a little bit more lazy, right, if I can say that. So I'm going to just drag this in here. Also, I do not recommend doing this if you're going for a longer and more serious project. I'm going to get my mesh. I'm going to set relative location. Okay, now I'm going to go to mesh, set the y to be -97, and then I think I need to edit the x. Let's see, -250. I'm going to copy this, put this in here, location 0, and this, and now I think this is going to work fine. Okay, so it's still not working. Well, let's see how we can fix this actually. I think this is too far away. Let's see, -100. Okay, so as you can see, -100 is going to work just fine, right? There's not going to be any problems with animations anymore. So this is how you can fix it, a really easy way, but lazy, and I do not recommend doing it. It's just something that you can do if you do not have better animations. Now let's see how we are going to create that particle system that I talked about, but we don't have any right now. So first we will need to create a material. So particle underline M. We are going to get a gradient. So let's say radial gradient exponential. Okay, we are going to multiply this with a color. It's going to be a vector 3. It's going to be somewhat of a blue color. Okay, then we can multiply this with a new value, just so we get that glowing effect. Okay, so we can have here 40 once again. Plug this in emissive. Then this is going to be translucent, and the opacity is going to be the radial gradient exponential. Okay, now let's see how this is going to look. And well, as you can see, this here is going to be masked, but if I'm going to get a plane, you can see that this is going to be a circle, right? And this is exactly what we want. Let's save. Okay, save. Now we will need to create a new particle system. So let's just wait here a second to save the material. So, new particle system, following particles, set the required to be the material that we just created, right? And you should be able to see them after the shade does compile. Let's set the initial velocity. Let's make this a lot lower, right? So we have minimum like this, and then 5, 5, and 2. Right, we don't want this to move too much on the z-axis. Then initial size, we are going to have from 5, 5, 5 to 15, 15, and 15, right? So everything is going to be 15. Then spawn, the rate, we are going to have a lot here, so let's see, 400. Let's save. Let's go back into the character. Set the particle system to be the one that we just created. Okay, so loading particles, plug this in here, and now right before the play from start here, we're going to get the particle system, and we are going to deactivate. So now the particle system is not going to work anymore, where the particles are going to disappear. Now let's play and let's see. Play. I'm going to press E, and you can see the particles behind me. Of course, if you're better at particles, you can probably do this better than me. You can also set the lifetime to be bigger. So minimum 1, maximum 10. And as well, set the spawn, the rate. Let's make this twice as big, so multiplied by 2. Let's play, and of course, as I said, if you're going to be better at particles than me, you can probably do this to look nicer, right? But as I'm not that good at particles and materials, I can't really get that good result that usually AAA games have. And that concludes today's video. I hope that you found this tutorial helpful and informative, and if you haven't understood something, let me know down below so I can help you out. This was a pretty long tutorial and pretty hard to make, so I probably missed some details out, right, so my explanation wasn't the best. So that's why if you really haven't understood something, let me know down below and I'd be more than glad to help you out. As well, if you want to learn more about Unreal Engine 4, both its features and how to recreate mechanics and game development in general, consider subscribing so you don't miss out on any of the upcoming videos. This tutorial is going to be, the project from this tutorial is going to be free on Patreon, so go on there and get the files if you want to try and see how I did everything, right? Try to experiment yourself. And that being said, thanks for watching and I'll catch you next time.